The agricultural system has done an amazing job of feeding a population that we never even thought would be possible on this planet. But that's come at a cost. Agriculture occupies nearly half of all habitable land, emits nearly a quarter of all GHG emissions, and is responsible for 70% of freshwater withdrawals. There is a better path. We need to find the exact right plant to grow in the exact right environment with the exact right inputs to make a more healthy, sustainable, and equitable agricultural system. I'm Brad Zamft, and I'm the CEO of Heritable Agriculture. Plants are these miraculous, solar-powered, carbon-negative, self-assembling machines. It's the most scalable technology that I can think of. After many years of studying biological systems in academia, I realized that actually one of the most impactful biological systems is the one that everybody on the planet uses to eat. It's the agricultural system. That's where I could create the most impact. One of the fundamental issues facing the agricultural system is the fact that it's expensive and takes a long time to breed new crop varieties. What that means is all of those small farmers don't get the benefit of the most modern agricultural techniques. I kept thinking, what if we could rapidly accelerate the timelines and change the cost of plant breeding? What if we combine artificial intelligence, predictive breeding, and biotechnology to be able to simulate how a plant is going to perform anywhere in the world? And that idea took off. Heritable has all the computational needs one would need in order to breed new crop varieties for any environment and any application. We run custom field trials to build AI-ready data sets to either predict how their plants or the crosses of their plants will perform anywhere in the world, or to understand better the underlying biology upon which you can build further breeding programs. These actionable insights include where farmers should plant the exact crop in the exact location, what management practices they should improve upon to get better yield or better properties, or the specific genetic elements that breeders need to focus on in order to improve crops for their ends. A good example of this is our field trials in Leamington, Ontario, Canada.
On a typical year, Tambury Farms produces around 1 million kilograms of strawberries, over 35 acres of production space. We're really happy and fortunate to be able to partner with Heritable to work on varieties that will work in Ontario for the future. It allows us small producers to get faster access to some of these new varieties, quickly grow them, quickly trial them to make sure that the markets get the quality, the flavor, and also us as farmers get the production that we need.
What's really exciting about strawberries is that the berry market is a perfect test case for finding improved lines that could provide better flavor, better disease resistance, lower price, and that are just more healthy and enjoyable for the end customer. Oh wow, it smells wonderful here.
Yeah, that's the perk of a strawberry greenhouse. It does smell good. It does smell good. Yeah, so these are some of the trial varieties we have. You can see the pro and the con of each. Some are struggling from the heat, some are struggling from mildew, and that's the data points that you guys are trying to get here. You can see this one here. It's a really nice, strong flower. This one shows some promise for us.
The crews today are looking at the shape, color, size, taste, and disease resistance. They're also taking samples of the tissue and freezing them in liquid nitrogen in order to be able to extract the molecular information that's inside those plants.
Yeah, this is the best looking, I guess. Those are the ones that they use.
Those samples are then shipped to our headquarters in San Carlos, California, where they're stored in an ultra-cold freezer at minus 80 degrees Celsius. When we're ready, our experimental team takes those samples and extracts the molecular information from them. This is the DNA, the RNA, and chemicals known as metabolites. Once they've finished purifying them and collecting those molecules, they send them off to third-party labs that convert those molecules into information. That's the moment that we move from the physical world to the digital world, from atoms to bytes. Those bytes are then sent to our modeling team, or further develops our AI models, which then provide actionable insight to breeders, farmers, and the agricultural system.
Artificial intelligence is moving so quickly, and we're getting to a point in biology where we can leverage these tools to really optimize plants in a way that we haven't been able to in the past. And it's an exciting time to be using both AI tools for biological modeling as well as for software development and scientific computing.
All of these data streams are incredibly complex. So we need a lot of computational power. We store huge amounts of information, and all of our models are run on Google Cloud. And behind that is a massive amount of infrastructure, data centers, operations that we don't even think about. That infrastructure has enabled a small company like us to be able to provide the insights and the impact that we want.
My hopes for this project here with Heritable is that we can more rapidly get varieties that are better suited for this environment that will help us overcome climate challenges, but also be more competitive in the industry to produce high quality strawberries and also a lot of them so we can be profitable as a business.
Besides the work that we're doing here, we're doing work in Nebraska and Wisconsin and of course California. So this project is really just an example of the massive impact that we could be having on communities around the world. I really do hope that in 10 years from now, we'll have an agricultural system that is using less fertilizer, less land, less water, that is feeding everybody in the world with high quality, nutritious food, and one that is in concert with nature, regaining our symbiotic relationship with the rest of the biosphere.